Good morning to all of you. So, in the last class, we have been discussing this Raman spectroscopy, and we have come to this point where we have to discuss the polarizability changes during the vibrations. So, मतलब बहुत बेसिक फैक्ट ये भी है कि ऐसा देखा गया कि कुछ मॉलिक्यूल्स में जो रमन स्कैटरिंग होती है, मतलब सम ऑफ द फोटॉन्स दैट आर बीइंग ऑब्जर्व्ड, द लाइट, द scattered amongst the scattered light, some of the light is polarized, plane polarized. ऐसा पाया गया कि कुछ a small fraction of that thing is plane polarized, and particularly it has been found in the case of methane, a perfect tetrahedral molecule like this. It shows so वो क्यों होता है और किस केस में होता है. Let's try to understand. मतलब you are using a source of light, a laser, to collect the Raman spectrum, and if you put in the when you are analyzing the scattered light, if you have a set of what to say polarizer and analyzer placed before the detector, you will find that some of the light is polarized. वो कैसे पता चलता है? अगर completely polarized हो गया है तो जब ये polarizer analyzer का angle 90 डिग्री होगा, then there should be zero intensity of the light. कोई पास ही नहीं कर पाएगा क्योंकि सबका oscillation block हो गया एक ही direction में. There is a only in this direction the electric field vector is oscillating if it is polarized, right? तो अगर ये थीटा 90 डिग्री हो जाता है, then there will be no signal. If it is parallel, analyzer is parallel to the polarizer, this axis, the theta becomes 0, and all the polarized light, if light has been polarized, it will be able to pass through. And if अगर intermediate situation के लिए at any given any other angle theta, there will be decrease in comparison to the parallel situation, there will be decrease in the intensity of light. तो इसी से पता चलता है कि आप दो बार इसको परफॉर्म करते हैं. एक बार एनालाइजर पोलराइजर पैरेलल रख के, एक बार उसको परपेंडिकुलर रख के, और दोनों का रेशियो लीजिए. If you find that there is a difference, then it is polarized. If there is no difference, then it absolutely no polarization has occurred. If अगर आपने परपेंडिकुलर कर दिया एनालाइजर को और तब भी वही इंटेंसिटी आ रही है लाइट की, तो पोलराइजेशन कुछ हुआ ही नहीं है. ठीक है. सो तो ये सारी चीजें जो यहाँ पे हम देख रहे हैं, ये जो नेचुरल लाइट लिखा है, ये एक्चुअली व्हाट वी डू इन केस स्पेक्ट्रोस्कोपी टर्म्स में जो भी हम कर रहे हैं, ये रमन स्कैटर्ड लाइट को हम यूज करते हैं. जो रमन स्कैटरिंग हुई है, we will tell here this is a general scheme of polarized light, but what we are doing here in particular, we are analyzing the Raman scattered light after it has fallen to the after it is incident on the molecule and then it getting scattered. तो उसके बाद उस सिग्नल्स को कलेक्ट करके आपको ये एनालिसिस करते हैं. सो दिस इज द वेरी बेसिक थिंग, एंड वी से दैट पोलराइजर एनालाइजर की कंडीशन में, परपेंडिकुलर कंडीशन में अगर कुछ लाइट पास हो रही है, देन देयर इज सम पोलराइजेशन. कभी ऐसा भी हो सकता है कि the light may not be completely polarized, it is partially polarized. मतलब most of the vibrations are in a particular plane, but some of them are also random. तो उस केस में जब आप एंगल को 90 डिग्री कर देंगे, in that case there will be the intensity will not go to zero, but it will be minimum. ठीक है. तो मैक्सिमम टू मिनिमम ये कल वाली क्लास में भी हमने डिस्कस किया था. और इस रेशियो को जब हम कैलकुलेट करते हैं, डिग्री ऑफ डीपोलराइजेशन रो, perpendicular, मतलब ये theta is perpendicular, so this theta between angle between, we are talking about the angle between and polarizer and analyzer, इसके बीच का जो एंगल है वो थीटा है, परपेंडिकुलर टू दिस, पैरेलल कंडीशन में सारी लाइट पास होगी, परपेंडिकुलर में अगर वो पोलराइज हो गया है तो कुछ भी पास नहीं करेगा, अगर पोलराइज नहीं हुआ है तो सेम इंटेंसिटी ऑब्जर्व किया जाएगा व्हेन यू पुट दिस प्रिज्म. ओके, so now, okay, so completely plane polarized light, degree of depolarization is 0. For completely unpolarized light, the degree of depolarization rho is 1. Okay. So obviously, if there is some polarization, the value must lie between 0 and 1. So it has been found that Raman signals of some molecules, not all, is found to be plane polarized, even though exciting laser light is completely non-polarized. So आपने normal जो light होती है उसको use किया without any polarization, and just scattering के बाद जो signal मिला उसमें आपको you are observing polarization. So how this is happening and under what conditions? So let us visualize this. This is the polarizability ellipsoid for methane. So this drawing is your ellipsoid for CH4 molecule. This is the CH4 and there is two visualization. So देखिए, so we have the incident light, ये आपका CH4 है, and this is the incident light. This is the electric field oscillation, oscillating electric field in, this is the direction of propagation light, this is direction of propagation of light. तो इस तरह से लाइट जा रही है, इलेक्ट्रिक फील्ड ऑसिलेट कर रहा है, और ये मॉलिक्यूल CH4 है जो पोलराइजेबिलिटी एलिप्सॉइड स्फेरिकल दिखता है. So you have a spherical, the ellipsoid is absolutely spherical. The A and B major minor axis are equal when you are having a symmetric stretching vibration. So this is ellipsoid of for symmetric stretching vibration. So during symmetric stretching, all the bonds, all the four CH bonds are equally stretching out, or they are compressing in. So the shape of the ellipsoid doesn't change. It is always spherical. Only the size of the ellipsoid changes. Okay, and this is Raman active, well known. But another thing that has been observed, which we are going to discuss, is this, that the Raman lines have been found to be polarized for such vibration. Symmetric stretching vibration जो मीथेन में होता है, उसका ये पाया गया कि जब हम ऑब्जर्व करते हैं, if we suppose you are sitting at the 90-degree angle and observing the scattering, the Raman scattered light, जो Raman scattering हो रही है, उसमें पोलराइजेशन, जो इलेक्ट्रिक फील्ड का ऑसिलेशन है लाइट में, वो एक ही प्लेन में है, दैट इज इट इज प्लेन पोलराइज्ड. सो लेट्स कंसिडर दिस वन. सो पहले जो ये लाइट की जो फ्रीक्वेंसी ऑसिलेशन है, सपोज इट इज गोइंग इन z डायरेक्शन, द ऑसिलेशंस इज हैपनिंग इन द z and y. So oscillation is happening in zy. So this is your zy plane. zy plane में oscillations electric field oscillates in zy plane. That's what you are seeing in the picture 1a, and it is incident upon CH4 molecule which is undergoing symmetric stretching vibrations. So what you know now is that during symmetric stretching vibration, there is a equal increase or decrease in CH bond length during the vibration for all of them simultaneously. Expansion or contraction is happening, so it will always remain spherical, only the size will change. Okay, so this kind of vibration actually resembles expansion and contraction of lungs, and we call them as breathing vibration or breathing frequency, and it is Raman active. So जैसे contraction और expansion हो रहा है, polarizability changes by a huge amount, and this is strongly Raman active. In addition to that, it has also been observed that these Raman lines, these Raman signals, okay, or Raman scattered light is also polarized, plane polarized, and that's what we are trying to understand, how this polarization of the light, जो स्कैटर्ड लाइट है उसकी पोलराइजेशन कैसे होती है, उस मैकेनिज्म को हम समझने की कोशिश कर रहे हैं. So first you should be able to understand why we call it breathing vibrations. Just like a lung contracts and expands during when you breathe, the molecule appears to be doing the same. ठीक है, इक्वल चारों साइड से एक साथ एक्सपैंड होना, एक साथ कॉन्ट्रैक्ट होना. So this is your breathing vibrations. Okay, and this breathing vibrations is giving rise to plane polarized light in the plane polarized Raman signals, the scattered light. So we are trying to understand that one. Okay, so what is happening here? एक minute. Okay. So when you have so this is the zy plane. अभी हमने कहा कि this is the zy plane in which we have electric field vector, oscillating electric field in the zy plane. The direction of propagation is along z axis. Z axis के along move कर रहा है, so it is moving along z axis, and propagation is happening in the oscillation of electric field in zy plane. So this is happening in a, here what you see is the zy plane oscillation in the zy plane. Light is propagating along the z axis, and so the electric field vector is confined in this. Now what will happen when the light is incident? Now the polarizability ellipsoid is equal in all directions. Okay, so induced dipole, the dipole that is induced, वो induced dipole कैसे create होता है? ये जो interact करेगा, scattering होगी, and as we have seen, the it will contract and expand with the vibrating molecule with the same frequency. Induced dipole will lie along the direction of greatest electric field vector. So electric field vector is all in this line. So it will be oscillating like this and emit out the radiation. The oscillating electric field will be, when the light is emitted, that after absorption, it will be all in this contained within this plane, which is now xy plane. So this is the Raman scattered light which we observe. The emitted signal will be have the oscillations in this plane. So ऐसा है कि when we are talking about induced dipole, it is, we have told you, alpha into E. So direction of alpha and E. So alpha is the polarizability. So this is what we have basically considered, and this is the electric field. Vector electric field किसका? In the light that is incident upon it. So the induced dipole can take the direction of either the polarizability or the direction in which the electric field is maximum. So electric field is maximum in this direction, and all of them keep oscillating in this, and they are, you observe a signal having all the electric field vectors in the oscillating in x y direction. So डायरेक्शन इधर से ऐसे आपको दिखेगा. So light, scattered light is seen through this, and it will be, so it takes up the direction polarizability in this particular case same in all directions, so the determining factor for the emitted signal will be this, the electric field vector takes so induced dipole takes up the direction is of the electric field vector in this particular case, जो अभी हमने केस डिस्कस किया. So because the polarizability is, so that's what it means, that greatest electric field vector is in the direction perpendicular to the direction of propagation, so that direction is retained by the thing. So ये जो oscillating direction जब इसमें देखेंगे तो आपको xy plane में इधर 90 डिग्री एंगल पे जो ऑब्जर्व किया जाएगा स्कैटरिंग, उसमें xy plane में कंटेंट रहेगा. So that means you have plane polarized light. So if the direction is limited to one plane, that will be plane polarized light. So the induced radiation will have will lie in xy plane, whatever be the plane of incident radiation. So the second picture, the B that we are talking about, it is of the incident light but at a different angle alpha. So it was initially 90 degree to the this xyz like this. Now this as यहाँ पे अगर any arbitrary angle alpha is taken, and now the molecule the same light is it is having electric field vector in this, oscillating in this direction. So it is here like this, oscillating electric field. So again the alpha is symmetrical, it is changing in same way in all the directions. So the direction that the incident scattered radiation will take, the emitted part will be the direction of the greatest electric field vector. So electric field vector is here, so it will keep oscillating in this plane. It is again, so oscillation के साथ ये जो light जो emit होगा उसमें सारा इस plane में सारा oscillation रह जाएगा, retain रह जाएगा. So that is, so again the oscillation of electric field vector in the Raman scattered light, if you are observing over here, it will be in xy plane. So this example shows that whatever be the direction of the incident radiation, what the emitted radiation, the scattered radiation that we are seeing at right angles to the incident radiation, यहाँ से जब observe करेंगे scattered radiation को, it will have only in one, it will have oscillations of electric field vector only in one plane, that is the xy plane. Agar if z is the line of propagation, so in both cases propagation is along the z axis. एक बार zy plane में oscillation है electric field का, दूसरे में z इस axis में अगर oscillation है electric field vector का, so we are considering a random oscillation for the electric field vectors in the incident radiation. Okay, और जब वो उधर जा रहा है और फाइनली जो इंड्यूस डाइपोल हम कंसिडर कर रहे हैं, तो वो जो इंड्यूस डाइपोल ऑसिलेट करना शुरू करेगा, ऑसिलेट जो करेगा, इट विल हैव द, सो डाइपोल विल टेक द ओरिएंटेशन ऑफ द ग्रेटेस्ट इलेक्ट्रिक फील्ड वेक्टर बिकॉज पोलराइजेबिलिटी हैज इज सेम इन ऑल द डायरेक्शन, सो उससे कोई फर्क नहीं पड़ेगा. So in both cases the induced dipole lies in xy plane irrespective of the plane of electric field vector in the incident radiation. So even if you are using non-polarized light, will contain all. So a non-polarized light that we will use along Z, it will have all oscillation like in this plane or in this plane. So along Z दोनों में incident है direction fluid, so carrying all values of alpha, but at every point we will have a radiation the emitted. So the oscillating dipole that will be induced due to the molecule is vibrating, and because of the vibrating, oscillating dipole is induced, and induced dipole, then oscillation of dipole gives out radiations, and the radiations have the oscillation of electric field in that is found to be in only in the xy plane. That is, you have a plane polarized light in both cases. So इस पर्टिकुलर केस में जो सिमेट्रिक वाइब्रेशन वाला अभी हमने देखा, रमन लाइन फॉर दिस वाइब्रेशन इज कंप्लीटली प्लेन पोलराइज्ड, एंड व्हाट वी विल ऑब्जर्व, रो इज जीरो irrespective of the nature of exciting radiation. Okay, so that was the example for symmetric vibration, breathing vibration. जो breathing vibration है, it will give polarized Raman lines in the spectrum. Okay, so that is one thing. Now let's consider the other vibration, the asymmetric stretching. So now we are going to consider the other vibration in CH4 molecule, asymmetric stretching vibration. So asymmetric stretching, the polarizability ellipsoid will be drawn like this. You can clearly see कि इस direction में polarizability, you have the stressed molecule, one of the bonds is stressed, CH bond, while this is elongated, other three are compressing. So you can see the movement. Look at the arrows. These three arrows are going inward. This arrow is moving away from carbon, towards the carbon, away from carbon. So this is asymmetric stretching vibration. To visualize it like this, this is your asymmetric stretching vibration. Now in this, and this is how we draw the polarizability ellipsoid for this kind of uh, asymmetric stretching vibration. Okay, CH4 molecule. So what is different here? Now the polarizability ellipsoid is not spherical, it is different in different directions. So it is more, polarizability is, so in this direction you have greater polarizability, minor axis, along this you have higher polarizability, and in this direction you have low polarizability. That's longer axis. Major axis has low polarizability. That's because of the 1 by under root alpha, the scale that we have taken for drawing the ellipsoids. So ये ellipsoid का एक view है, and because so now what will happen? Now suppose the same event. In this particular case, when the asymmetric vibration happens, spherical symmetry is gone. It looks, and this is the extreme situation of vibration that we are visualizing here. So now again you think of this mu induced will be alpha E. Now the polarizability ability, this is different in different direction. In previous case, when the vibration was symmetric, the polarizability was same in different directions, but here in this case the directions will depend, polarizability alpha will be different in different directions. So if the depending on the, so the induced dipole will take up the directions, so it will, induced dipole will take up it will start oscillating in the direction of highest पोलराइजेबिलिटी. सो उस इंसिडेंट पे जिस डायरेक्शन में ज़्यादा पोलराइजेबिलिटी है वो वाला डायरेक्शन ले लेगा. सो दैट्स along the minor axis of the ellipsoid, along the, so it will lie along the minor axis of the ellipsoid in this case. अब देखिए कि within a container you have large number of molecules and all of these molecules are vibrating and at the same time they are also undergoing rotation. So इसका मतलब ऐसे कई सारे एलिप्सॉइड होंगे. एक अगर ऐसे it is oriented vertically like this, the other will be oriented in different fashion. So overall situation will be that you will have there will be so many different directions of alpha. The polarizability will be having all sorts of directions, so there is no net uh, no net overall direction that will be possible, and the oscillating dipole will be observed. The dipole, induced dipole, will oscillate in all possible directions. एक को विजुअलाइज किया तो उसमें हमें इधर दिख रहा है कि डायरेक्शन ऑसिलेशन इस डायरेक्शन में होगा. द हाईएस्ट पोलराइजेबिलिटी इज दिस, emitted dipole in this, but there will be another molecule in this, because it is, you can think of a container which will have large number of submolecules and polarizability ellipsoids will be different, will have major axis, minor axis in different directions. So if you are having a large container, it will have like, see, कोई ऐसे होगा, कोई ऐसे होगा, कोई इधर होगा, कोई इधर होगा, like this. So they will, in a container you will have large number of molecules and you are not sure in which direction they are oriented. So they will be, so when we are looking at the direction of easiest polarizability, it is different for different molecules within the same container, within the same vessel. So ultimately the thing is that you have all sorts of directions of polarizability, and so the induced dipole also takes up random directions, and in this case you observe no, so because if the induced dipole oscillates in random directions, they are not contained in a plane, the Raman scattered light is not polarized. So यही चीज डिफरेंट था जब हम पहले विजुअलाइज कर रहे थे. तो ऑल, in case of symmetric vibration, all of while the molecules are rotating, the if you are looking at symmetric vibrations, that is not changing. The ellipsoid is same in all the directions, it has same polarizability in all directions. So वहाँ पे वैसा नहीं हो रहा था. यहाँ पे polarizability का directions हर बार हर molecule में अलग अलग होगा, because they are under constant random motion, they are moving, having rotating molecules, and so polarizability directions for when you are visualizing this kind of asymmetric vibrations, asymmetric stretching vibrations, it will have random orientations. So there will be so many minor axes, so many molecules within a container. So because of lack of spherical symmetry, the induced dipole gets randomly oriented, and it is completely depolarized light. The scattered radiations are depolarized completely. This time the direction is taken up depending on the polarizabilities direction. In previous case, we didn't, the alpha was same in all directions, so it was not a matter of concern. But here alpha is different in different directions for a given molecule, for one single molecule. There's so many molecules in a container, all will have random orientation, so polarizability have a lot of uh, different directions. And so the conclusion here is that what we conclude here in taking example of methane, what we have understood here is that the totally symmetric vibrations, such as the previous one where you have a spherical ellipsoid, So polarized Raman lines will be observed, whereas non-symmetric vibrations such as asymmetric stretching, the one we have just discussed, it will give completely depolarized light Raman lines. Non-symmetric vibrations, depolarized Raman lines. Symmetric vibrations, completely polarized Raman lines in case of such a spherical top molecules. Okay. Uh, so so this is now we are moving to a generalization of the thing over a large number of different types of molecules. So what will be the thing? So general considers symmetric vibrations. So when we try to generalize the trend, we what will this is what the trend is. Symmetric vibration give rise to polarized or partially polarized Raman lines, whereas non-symmetric vibration give rise to depolarized lines. This is the general statement. And how do we say? How do we say that something has been polarized? The degree of depolarization is to be seen. If it is less than 6 by 7, we say it is polarized. If you are observing Raman signal and you calculate the depolarized degree of depolarization, if it is less than equal to 6 by 7, it is polarized. If the degree of depolarization is greater than this value, then we say that it is depolarized. So this is the case for non-symmetric vibration. The previous one where you observe polarized, it is for the case of symmetric vibrations. So in general, what you will find, the linear molecules, symmetric top molecules, spherical top. So you, if you observe symmetric vibration in all different types of molecules, linear, symmetric top, spherical top, तो जैसे जैसे सिमेट्री बढ़ रहा है वैसे डिग्री ऑफ पोलराइजेशन भी बढ़ता जाता है. So increasing symmetry, increasing polarization of the Raman lines will be observed. Okay, तो जैसे linear molecule होगा CO2, spherical top molecule CH4. So in CH4 molecule, the most symmetric vibration had completely polarized Raman lines. मतलब I परपेंडिकुलर करने पे आपको जीरो इंटेंसिटी मिल रही थी. CO2 के केस में जो most symmetric vibration is stretching vibrations, symmetric stretching vibrations. In that case, so what we have seen here, CO2, this is example of CH4. So this is the two extreme situations we have. So left to right, we have increasing symmetry and increasing polarization of the Raman lines is observed. Okay, and yes, so they will be here. It will be partially polarized, symmetric stretching. Sorry. So if we try to observe symmetric stretching vibrations in all of them, so if you try to, so what we mean here, for symmetric stretching vibrations in all these, symmetric stretching in linear molecules, symmetric stretching in spherical tops, so you will have it, these lines will be, all lines will be appear to be polarized, but the degree of polarization or will be high in this left to right. So which means it will be partially polarized. So what we mean is, if it is partially polarized on this side for the linear polarized thing, for linear molecule, on this side it will be completely polarized, but you will observe polarized signal for all the symmetric vibrations. अगर ये partially polarized होगा तो इधर वाला completely polarized आपको lines मिलेगा spherical top molecule में, perfect polarization of the Raman lines. So this is the trend that has been observed. Okay, so अब आपको now you know the infrared spectroscopy, you also know the microwave spectroscopy. So rotation, vibration, that you know. You also now know the Raman spectrum, vibrational Raman, which we have discussed. Based on this, if you are given infrared Raman spectra, you can analyze and get to know the structure of the molecule. So there are several factors on which it will depend, and you can assign the bands accordingly. So structure determination will depend on these many factors as given on your screen: number of fundamental vibrational modes, vibrational frequency, the appearance of a Q branch. We have discussed earlier in raw vibrational spectroscopy, linear molecules do not have Q branches, parallel vibrations in the linear molecules. So then you follow, also observe the rule of mutual exclusion, see the vibrational dipole moments and polarizability, and also observe the depolarization of Raman lines if it is observed or not. Polarization or depolarization, whatever you may call it. So it will depend on what. So you have to assign the bands कि आपको बहुत सारे वाइब्रेशनल फ्रीक्वेंसीज के करस्पॉन्डिंग CM इनवर्स वैल्यू के साथ इंटेंसिटी का उसमें ग्राफ में मिलेगा. अब कौन सा किस तरह के वाइब्रेशन के लिए उसको असाइन करना होगा. यू हैव टू असाइन द, दैट इज कॉल्ड बैंड असाइनमेंट, कि ये वाला बेंडिंग के लिए है, ये स्ट्रेचिंग के लिए, सिमेट्रिक स्ट्रेचिंग के लिए. सो ऑल दिस थिंग हैव यू हैव टू आइडेंटिफाई एंड assign band assignment. So you must know, the first thing is that when you are given a molecule and you are given the spectrum of Raman spectra, infrared spectra, you will first find out the number of fundamental vibrational modes. So 3n minus 5 we have already discussed. Not just the formula, how this formula comes about, we have discussed earlier. Now further, linear molecule, perpendicular vibrations are always doubly degenerate, as we have seen the bending mode in case of CO2, and in case of CO2 it appears the bending mode is degenerate, appears as a single band. So that is one. Hot bands, you know, the higher level excitation 0 to 1 to 2, 0 to V0 to V2, V3, sorry, hot bands will be the one, the transition starting from the excited vibrational levels. So hot bands, so this kind of thing was your hot band, higher, the which you can observe when you heat the sample above the room temperature, and you find that new signals come up, and that corresponds. So these hot bands will be very less, intensity will be less. That means we say it is less intensity, very weak, because the population will be less for those at room temperature, those are less populated. V is equal to 1 or V is equal to 2, that will be less populated, but as you increase the temperature the signal increases, and so on heating you get those bands. So that's why we call it hot bands. When you heat the sample you get those bands, otherwise not. So these things will be very less. Hot bands you don't have to be much worried about. ये सब consideration में आपके नहीं आता है usually. You don't have to worry about that. Unharmonic leads to overtones. तो अनहार्मोनिक सिटी की वजह से V0 से 1, 0 to 2 वो वाला ट्रांजिशन भी होगा. सो ओवरटोन्स विल ऑल्सो बी देयर, बट ये सब चांसेस बहुत कम है. सो हॉट बैंड्स एंड ओवरटोन्स, so there are two things that all these things will be very less. Overtones, hot bands, very weak. That means when we say very weak signal, that means low intensity. We are talking about the intensity. Weak और strong जो हम कहते हैं वो इंटेंसिटी को लेके होता है. दिस इज इन टर्म्स ऑफ इंटेंसिटी. So fundamental bands will dominate the spectrum, and you are mostly concerned with that. Okay, so you don't, so only focus on this fundamental bands. Okay, then so number of fundamental vibration modes. Observe the spectrum. It will be, then the vibrational frequencies, bending modes will be all obviously the lowest frequencies in, or lower wave numbers. Asymmetric stretching modes will always be highest. So always remember, above 2500 cm inverse there must be hydrogen atom involved. So CH, so for example CH vibrations, OH, NH, they all, these things will appear above 2500 cm inverse. 2500 cm इनवर्स के ऊपर सारे H हाइड्रोजन एटम कंटेनिंग जो ग्रुप्स है, फंक्शनल ग्रुप्स हैं, उसके वाइब्रेशन मिलेंगे आपको. सो दीज आर तो, सो ये सब अगर पता है तो आप क्विकली एनालाइज कर सकते हैं. यू कैन एनालाइज वेरी वेल कि कौन सा मॉलिक्यूल हो सकता है, क्या हो सकता है, जस्ट लुकिंग एट द स्पेक्ट्रम, infrared spectrum and Raman spectrum. Okay, then you look for the Q branches. Third thing that you have to take into it. So पहले आपने आइडेंटिफाई किया कितने नंबर ऑफ फंडामेंटल वाइब्रेशनल मोड्स हैं. सेकंड, आपने स्कैन किया कि लोएस्ट वाला किधर है, हाईएस्ट वाला क्या आ रहा है स्पेक्ट्रम में. तो उस तरह से आपने स्कैन करना, बेंडिंग मोड्स का आइडिया मिल गया. एसिमेट्रिक स्ट्रेचिंग होगा तो हाईएस्ट साइड में होगा, और उसमें भी आपको हाइड्रोजन एटम अगर इन्वॉल्व है तो पक्का 2500 सेंटीमीटर इनवर्स के ऊपर कुछ वाइब्रेशंस आपको मिलेंगी कहीं ना कहीं. और सो काफ़ी कुछ क्लियर आइडिया आपको एक अननोन मॉलिक्यूल के बारे में मिल सकता है अगर आप ठीक से ऑब्जर्व करेंगे तो. देन यू लुक फॉर द क्यू ब्रांचेस. सो यू जूम इन टू द, focus on one of the vibrational peak and zoom in further to see the rotational fine structures. क्या आपको क्यू ब्रांचेस दिखता है, नहीं दिखता है? So the presence of Q branches in IR indicates a non-linear molecule, ठीक है, or a bending vibration in a linear molecule. So आप, so आपने बेंडिंग को वहाँ पे आइडेंटिफाई कर लिया, उसमें अगर Q ब्रांचेस है या आपका स्ट्रेचिंग वाइब्रेशन है उसमें Q ब्रांचेस नहीं है. अगर Q ब्रांचेस है तो नॉन लीनियर मॉलिक्यूल है, अगर पैरेलल, ठीक है. सो दीज आर थिंग्स दैट वी हैव आल्सो डिस्कस्ड अर्लियर. If these have no Q branches, the molecule is linear. ये बहुत सीधा, molecule is linear if no Q branch appears in stretching mode. Stretching mode को देखिए, stretching mode higher frequency side में होगा, bending mode lower. So highest, so first you look at the stretching modes, और उसमें Q branch अगर नहीं है तो molecule is linear. Generally this is the thing that you have to consider. Rule of, then look for the सेंटर ऑफ सिमेट्री. मॉलिक्यूल में सेंटर ऑफ सिमेट्री है कि नहीं, तो आपको, so you look for the center of symmetry in the molecule. If it is there, so accordingly you arrange the atom. एक आप स्ट्रक्चर बनाना शुरू कर देते हैं. so म्यूचुअल एक्सक्लूजन क्या था, जो रमन एक्टिव लाइन है वो IR में नहीं मिलेगा, और IR एक्टिव है वो रमन, so रमन एक्टिव नहीं होगा. so नंबर ऑफ स्पेक्ट्रम आप दोनों का मिला के आप देखते हैं कितनी लाइनें इधर आई, कितनी उधर आई, जो इसमें आया वही वाला उधर है या नहीं है. तो अगर वो एक्सक्लूजन रूल फॉलो कर रहा है तो डेफिनेटली इट हैज अ सेंटर ऑफ सिमेट्री. वाइब्रेशनल डाइपोल मोमेंट्स एंड पोलराइजेबिलिटी. सो व्हेन यू, so if you have a very large dipole change, the signal will be very good, whatever strength of the signal of IR band, or so in case of infrared spectroscopy you will have a very good signal. और अगर आपका पोलराइजेबिलिटी में चेंज ज़्यादा है then Raman band will be very good, very intense. Okay, large change in dipole, strong IR signal, large change in polarizability. If you have significant change in polarizability, you will have strong Raman signal like this. So depending on what, so you have to observe these things when, जब आपको मॉलिक्यूल बताया जाए, फार्मूला बताया जाए मॉलिक्यूल और फार्मूला, और उसका स्ट्रक्चर इवॉल्व करना बेस्ड ऑन द स्पेक्ट्रा. So symmetric vibrations, so fundamental thing, more symmetric is the vibration, more Raman active mode it will be, Raman activity will be more, signal इसका ज़्यादा strong आएगा. Polarization of Raman lines. So Raman lines, so जितना more breathing vibrations are the most symmetric vibrations, जो equal symmetric stretching वाला जो हम कहते हैं. And in case में you will get complete polarization. For some other modes, other molecules, if it is not spherical top but has a symmetry like CO2, then also there will be some polarization, but to a lesser extent. So something that is less symmetric as compared to tetrahedral, that will also show some polarization. And उस तरह से आप deduce कर सकते हैं. So we will take some example and analyze, तो ये सारा clear हो जाएगा. So we have already seen non-symmetric vibration give rise to depolarized lines. Symmetric vibrations give rise. So when you are talking about linear symmetric top and spherical top molecules, so increasing symmetry left to right, symmetry of molecules increases, and extent of polarization will also, in the Raman signal, the extent of polarization will increase. So the conclusion, symmetric vibration may be partially polarized in linear molecule, but it will be completely polarized in spherical top. We discussed this thing earlier. So based on this, you can do assignment. We will do this in the next class. Based on this principle, you can do this band assignment and structural determination. We'll follow it up in the next class.